glad to see you here after the lunch. Hope you're not sleeping, but I'm fine if you do. So my dog is called Debug C++ without running, but actually after a couple of runs for these talks, while I was updating it, I came out with a second title that is Fruitful Reading of C++ Code. And as I said during the conference opening, I'm not going to teach you how to write readable code. That's another big topic, and there are many speakers at this conference who can do that for you. But I would be trying to explain how to read the code that maybe is not that readable, or it is readable just because it's a regular C++, but it looks a little bit unreadable. So a couple of words about myself. So I was a C++ developer for many, many years in different embedded and networking stuff. And then I moved to JetBrains when I'm officially called Product Marketing Manager. I'm trying to be something between marketing, product manager, and developer advocate, so somewhere in between. And actually my passion is using tools where we need them. And I'm pretty much sure that in many places in our development cycle, we do need tools, and we shouldn't ignore them. And so, as I promised, this talk is about reading the code. But let's first of all see about some state of the C++ developer ecosystem and what we had there and how do we feel about it. So I will start with a couple of surveys. So the first survey is a survey that we've run by JetBrains 2 times in a row already. It was 2017, 2018, and currently we are running 2019. So if you would like to participate in the C++ part, just go to that link here and fill the survey for the C++ part. We'll very much appreciate your input. So in 2017, the C++ developers in the survey, we collected like 1,700 responses from C++ part. So in 2018, C++ developers, number of C++ developers who participated in the survey were 4,700. So it's quite a lot. And so I think that this number, yeah, that's fine. These numbers can be quite representative in that sense. So, and I would like you to pay attention to that spike here. And this is C++ 11. So that's what most of the people, like nearly 60% of the C++ developers in the modern world, are using C++ 11. And quite many, nearly 1/4, are still on C++ 98. C++ 17, actually, yeah, it grows. That's fine, because like the standard was officially signed, so we were expecting that growth. And so I'm very happy to see quite many respondents who said that they are planning to move to a new standard, and like some of them even planning to move to C++ 17, which is also nice. But still the numbers are showing us that many people are still using the older standards. And there are many reasons for that. Part of these reasons are legacy code, but part of the reasons, I think, is the complexity and some overhead we got while reading the code in C++ and trying to deal with that. And yeah, the funny fact about this, all these things, that also in this survey we had a question about using the unit testing frameworks in C++ world, and more than 40% of the developers are not using any unit tests at all. That's all I want to say about the unit test here. So the C++ Foundation also ran a survey in 2018. The numbers are pretty much similar. They got 3,200 developers who actually filled the survey, and they got nearly the same numbers. So you can see the standards like C++ 11 here, and so they have like several questions. So like if you're using pretty much all the features, that's green. Yellow is that the standard is not allowed, and the blue is that it's allowed just partially. So some features are prohibited and some are allowed in the company. And you see what's going on there. So many people are still at like C++ 98 and C++ 11. In general, at least they are using most of the features from there. And there is a very interesting cloud that the foundation actually collected, that one. That question was about the feeling, how the people feel about the C++ language, and about why do they consider it difficult, or why they don't use it. And in that cloud, you can see these words like difficult to understand, or some lack for some documentation, and just difficulty again here, and some other reasons. So yeah, and that hard to understand in that part of the cloud as well. So many people do find C++ difficult, at least to read and to understand. And as many of you probably have heard, most of the time the developers are usually reading the code, not writing the code. And if it's difficult to understand the language, that's a very tricky exercise, actually. And so if we summarize a little bit how the C++ developers feel about the language, here in UK, nearly a year ago, at ACCU booth that we run with JetBrains, I've heard that phrase that C++ developers must suffer. That was the answer from someone who came after my talk and told me about that. And from one point, I maybe agree, because when we do suffer, when we do struggle, we think more about what we do that more thoughtfully. But really, should we? Can we just do it easier? Can we just deal with the language a little bit easier? Also, there are some description for our difficulty in C++, and some people find that the cognitive overhead in C++ is quite big. And some people think that we actually need something more simpler and something more debuggable, in the sense that we can read it easily. And I really like the direction taken by some members of the C++ community, like Herb Sutter, for example, who really struggles a lot towards a more powerful and simple C++. So he would like to join these 2 points. So we need a more powerful language, but at the same time, we need to keep it simpler and to make it simpler. And since I took the second and the third quote, it's actually for the big thread that happened this year, this autumn, and in December as well. You might be heard about that. So Eric Nibbler, who is an author of Rangers in C++, a very notable feature, and I'm really thankful to Eric that he make it work, and he actually made this huge progress that the Rangers are now in C++ 20. We will have them quite soon officially. And he actually wrote a blog post explaining how the Rangers work, maybe using not a very successful example, but still he was explaining how it all works, what are the benefits. And then the flame started. So there were many people from game development who were sharing this vision that the C++ goes the wrong way, that it's getting more and more complicated, and they can't work with the language with this cognitive overhead that they have to deal with. And since many game developers are with C++, because as you know, in game development world, you either do very simple games with Unity, or you do big and reasonable games, but in C++. You either use an Unreal Engine or your custom C++ engine. So all the AAA games are in C++. And it's kind of complicated to find developers who can deal with the language and implement and maintain the game. And so they have some pain, and they have some requests for the language. And so that was that Twitter thread started by RS and some posts where he shared his attitude to the language and what's wrong with the Eric's post. And then there was a nice follow-up by many people about that. But I just took a couple of quotes from that threads, which I would like to share here. One of the quote was saying that the way C++ is changing is scary. So the people are scaring how the language evolves. While the general goal for C++ community is to make language better for us, usable, fitting our tasks. But some people are scared with how it evolves. And also, some people say that the language they want, it needs to be debuggable. And they don't see how they can debug the current language features easily. And then there was this another thread which was saying that, maybe there are some creepy features, but no one will be using them. But then it was noticed that if there is some feature in the language, someone will use that. And the thing that bothers me about the language, about the C++ in particular, in that sense, is that some of these people are actually quite correct about the language. So they are really scared. And what scares me, for example, is that in C++ we have 10 ways of doing one thing. And that was also mentioned in these threads after the Eric's post, that the C++ language provides you sometimes too many ways of doing one particular thing. A very simple example, initialization. So there was a talk by Nika at CppCon I really recommend you to listen to that. That's just a slide about initializing an integer. And there will be a Tima's talk tomorrow about, again, the initialization. This is a nice table he will share tomorrow. Just grab a link from him and print it and put it near your working place about different type of initializations and different details you have to know about them. So it's not that easy even to initialize a variable in the C++ language. There are many ways of doing that. So sometimes it's good or bad. There are reasons for having that many ways, because we need to solve some particular tasks and some new type of initialization appears because of that. But sometimes the newbies who are coming to the language, they are just scared with 20 ways of initializing an integer variable. Talking about 10 ways of doing one thing, a very simple example from our life, when we were implementing some feature in C-line ID in JetBrains, we have a automatic tests, and we also have quality engineers who are doing some manual tests. And so they actually came up with that very simple example, and something was broken on the example in the IDE. And naturally, they created an issue for the developer. Developer actually came and investigated what was going on there, and then the developer actually asked, why this example? So what's the meaning of this example? And the example was just the quality engineer was just playing with some language features, trying to construct some example that could break an IDE. You know, that's what the QA in the IDE worlds are usually doing. They're playing with the tricky language. And so we started looking at this example with the whole team, and we were a little bit surprised, because what actually this code is doing? Why is that complicated? So the first effort was very simple. We put it, what we all do in C++. We put it to Godbolt, to Compiler Explorer. So nothing, because that's an obvious code generated there, but it doesn't explain us what the code is actually doing. So I can run this code, but it won't explain anything to me. Why this complexity? And then we decided to change it a little bit. So we wrote the variable template using a different syntax. Then we removed the template completely, and then we removed the cast. And so we end up in the code that is just returning 42. That's the same. So this is the way to write return 42 in the main. We found an issue in the IDE. We fixed that. We closed the ticket. But we were left with the feeling that something is going wrong. So because we created actually an example of code which is compilable, which is fine, which is absolutely correct in terms of the syntax, but it does nothing more than just returning 42. And we can do that with the language. So if you're not doing something thoughtfully, you might end up in a very complex code which doesn't do any complex things. Regarding the understanding the code, there is also one nightmare in the language that we still have, and that's of course macros. We still have them. We still have to deal with them. Some lucky developers can avoid them, but I don't think we all can, at least now. And the biggest issue is that these macros in C and now in C++ language, they're just including everything everywhere. So just a textual substitution. No context, nothing. So, for example, here in that example, what you have, I have some crappy file called xmacro.txt, which looks like that. So it's not a valid code, it's just some text. And I have some define, which creates some enumeration for me. And when I undef this macro, I don't have any trace of what was going on there. And that's what I actually did here. And then I had this switch case operator, which actually goes through all the values. So first question, where to take the values? Did I take them all? I'm lucky enough that the compiler shows me a warning that I'm missing some switch case, or I'm very lucky if my tool suggests to generate some switch cases for me and I don't have to think about that. But when a person is looking at its code, these are the natural questions, are we covering all the cases? Should we add something more? Where are these values are actually taken from? What's all of that? So what's going on there? And it would be nice if the tools can help me to answer these questions, because sometimes we have to deal with the code looking somehow similar to that. Another example for the macro is like that, when I have some class definition. And so I'm defining a class, I have some members in this class, And here, when I call this macro with some value, a whole class definition appears with all these members. And if this macro is defined in some other file, so I have to go to that file, find out this macro definition, understand what's actually behind this macro to understand what I will get here at that point. And our example that I was shown during the talk presentation in the morning. I like the example a lot. I call it magic. And it's actually, it might look unnatural, but that was built from the code that was a real code, so it's just a very, very simple version of that. So the idea is here is that I have this test function, and I have that very last line here. And the question is, either this is an expression or it's a template instantiation. And the answer is here. It's under this magic. So, and it actually depends on this magic. So it's either a template instantiation or it's an expression. And it depends on the value of magic, which could be some compilation flag, or it could be defined somewhere in some header, also depending on some compilation flags, and so on and so forth. So it could be hidden somewhere deep inside your code, or the library you are using, or some other part of the code that you are not maintaining, whatever. And it could make sense. So you would like to understand what's actually written in that line of code, but you can't without knowing this magic value. And so we also have these function and operators overload, which are not very complicated on their own. Like function overloads, that's just a set of rules. So you have to build a set, you have to filter it properly, you have to select the best fitting candidate. That's very easy if you can do it in your head. So here, the answer will be printing 2 and 2, if you can calculate it quite quickly. And if I change the second call to using like 1.0, I'll get 2 and 9, if you can calculate it quickly, and so on and so forth. So I can like run the program, see the output. That's very easy. I will get the value. But how you can do that in your head? How you can understand that the proper overload was selected? What was the overload? Why was it selected actually? Especially if you have the whole overload set spread across the whole solution. Another question here is like operators. We can overload operators. That's a very powerful feature of the language. But how, when you're looking at the operator, to understand that it's actually overloaded? So because here in the last line, where I have this stdout printing, half of the operators are the standard stream operator, and half of them are overloaded for my fraction class. They look the same, but they are not the same. They are doing different things. And that's always the question when you look at C++ code. Is this plus is actually a plus? Or is doing something different? That's like maybe that looks like examples with which we can scare, C++ students. But that's not examples to scare. That's our real world. We have to deal with somehow. And we might say that let's avoid all the scary things and read a very clear and readable code. That's a very nice goal, but do we always follow it? Do everyone in the C++ world follow it? Unfortunately not, so we still have to deal with that. And more nice things are coming, actually. This is the metaclass example from the Herb Sutter's proposal. And the idea is that you have the interface shape somewhere in the future of C++ world. Then you have some metaclass. And then after the compilation, you get this shape struct in the end. You never have it in the original code. You just have this interface. So how would you understand what you get in the end? That's a very interesting question. So, and at that point, Herb actually called some C++ features the professional hiders. And that's what I call all these things. So these are professional hiders who are hiding the actual meaning of the code from the developer who is like writing this code or reading this code. So understanding the code, there might be a very easy way, like you run debug, test, or like run your application and see the output. But first of all, the compilation can really take a long time, and you don't want to wait for the whole solution to compile just to understand one line of code. And maybe there is some issue with the compilation, and why should it prevent you from just reading the code and understanding its meaning? Then sometimes to like run the code, you have to deploy it, and there could be a different platform that you don't have at the moment. There could be some complicated deployment process, and the target platform can be different from the platform at which you are developing at, and you might not have access to the target platform at the moment. So to run the code at some remote platform, you need to have access to it. Also, the code could be incomplete. I mean that you can be just implementing a library, which you might cover with tests, and it's actually good when you have some tests for a library so that you can actually run some functions from your library. But still, when you're reading a library, to understand the library, do you have to like run all the tests or to implement some tests using this library code, or can you just read it and understand what's going on there? And also, like there are various tools like static analyzers with like plenty, dozens of different useful checks, but maybe there is no actual issue or error in the code, but you just want to find some flow in logic or just to understand the meaning of the code, so just to get this understanding. And so all these things are about how transparent the language is and how language features are hiding things from you. And so I'm really thankful to Herb, who summarized that at cppcon in 2017, saying that the current abstractions in the language are real hiders, and we do need tool support to understand what's behind these hiders, what they're actually hiding. And the very last point is the point that I really love as a tool vendor, that the good abstractions need to be toolable, because some C++ abstractions are really hard to be toolable. And we'll talk about that a little bit later. So yeah, and actually all this talk, it started with this slide from Herb Sutter from that talk, when he was trying to suggest some features in the modern tooling which could help to unveil these language abstractions. So let's start with that first, that we would like to help C++ to be debuggable, to be more readable. So my idea here will be to present you what we have in the current tools ecosystem that can help you to understand the code, to read the code, to debug it in that sense. And we'll start with the macro debug. So and the goal is actually to understand the substitution before running the preprocessor, so just looking at the code. So what do we have here? So I will try to mark all the features that I show here with this little ID mark so that you know which one is coming from which tool. There will be Visual Studio, Eclipse, like JetBrains tools and some others. So that you know where this actual feature is coming. So showing the final replacement, that's the idea when you call something on your macro call, like in C-line you call the quick documentation pop-up, and it shows you the final replacement for the macro. So like that. So you just go to the macro call, invoke this pop-up, and you get the final replacement. So it doesn't substitute anything into your actual code, you just see it and understand what's behind this macro. A very useful thing that will just substitute everything for you for the whole stack and show you the final substitution. There's a very good point that you don't need to change your code, so that's just a separate window, and it doesn't change the semantic, and I will explain it a little bit later. There is another approach which we took in C#, and that really helps you debugging the macro in a very natural sense in which we got used to. So it helps to unwind the macro substitution stack step by step. Like for example here, I'm just substituting the next step, and I can then call it once again. It will substitute me the second macro here. So it's good because you just unwinding the stack step by step, and you can stop at any point. Maybe you don't need to see the final replacement, because for example, for boost macros, the final replacement is just one page of C++ code. Maybe you don't want to see that long page, you just want to see some intermediate state. So unwinding step by step might be very useful for that goal. And you can actually stop at any point and decide, like, yeah, now I got it. Now I understand what's going on there. And you can also like substitute all the steps and get the same as in a very first example in C-line, but it just substitutes everything in the actual editor for you. A little bit more practical example of that substitution is like here I have the boost pp repeat macro, and I would like to understand what's going on behind this macro call. So what I can do, I can go and substitute step by step, see how this stack unwinds, trying to understand how this macro actually works, and in the end, I get this line here. So yeah, if you would like to understand what boost is actually doing, that's a very nice thing. I see some people are laughing. I hope you see this code every day and you know what it's actually doing. And so yeah, and you can find some feature that can help you in that sense. When I said that you should be careful with the context, there is a very tricky example. So for example, here I have some macro definition here, and I have 3 lines. At each line, I'm calling this macro. And this macro is using the counter macro. So it increases every time it sees the counter macro, so just increasing counter. And so in the ideal world, when all these macros are substituted here, I will get these V0, V1, and V2 macros here, like variables here. But if I substitute the second uvar line here, I will get the following. So I get the substitution here, so I have this V1 variable, and then like any IDE will put some red squiggles here, and the reason for that is because it will be counter used here, it will be counter used here, so in that line I am also defining the V1 variable. So because the counter and like the line macro, for example, they depends on the context. So when substituting the macros, you should be very careful because you can affect that context and then something will change. So the result, after my substitution, the result doesn't look the same as if I just put the preprocessor on all my code. Another thing which you have to think about when you're trying to debug macros is that that's a very complicated task for the tool. And that's the reason why. Since macro is just some text substitution which happens somewhere in your whole solution, and the tool actually has to find for all the usages for some text symbol. So that's what most of the IDE are doing here. If I have this, I have the function with the variable parameter, integer parameter, and double parameter. I have some defined here, and if I put the cursor on this func here and try to navigate to the declaration of this func, it usually shows me this one. So if you see like that, what Visual Studio, Eclipse, JetBrains tools are actually doing. So we're just showing you these 2 lines. And what we doesn't show you is this usage, where I have again this symbol. It just had different meaning. And I had this macro call here. So, and it's a very complicated task to show you this option in that very dialog. And so we, in one ticket, we had, in our issue tracker, we had a long thread discussing how it should be working, and some people were trying to explain that in like 80% of the case, you can create some heuristic where to go. But you know, with C++, it's not the 80%. Usually you can create a couple of heuristics that will serve like 20%, and the rest of the 18 will be unserved. So macro debugging is a very complicated task because it's not easy to find all the usages. So all these features, you have to use them with care because of that. Okay, so we can debug the macros. Can we debug types? So the goal is the same, understand the file type. And so we can have like example like that. This example is a very strange C++ example, like we could say about it like 10 or 20 years ago. Now it's fine for us. So there's the C++ where no type is used, because we have auto and we have decl type, and so there is some type inference happening here. And so the actual type of this op variable, this operation is actually deduced from the actual usage of this doOperation function. So here the operation is just double. If I use the integer parameters for my doOperation, it will be integer. The good point is that every IDE, and that's the main difference from the IDE from the text editor, that every IDE is building a full AST for your code. And that means that it actually knows the type. So it's very simple. It can just show it to you. That's what all IDEs are doing. So that's the Eclipse is showing the double type here. C-Line and like Visual Studio, starting from like this summer is also showing this. So they can infer the type, they can show you this information on the fly. So if you change the arguments, the integer arguments for the do operation, you'll get the integer type. Okay, the next thing is the using of the typedef. And the same story as it was with the macro when we were unbinding the stack. There is a feature in ReSharper C++ which suggests you to unbind the typedef stack. So it works the same way. You can substitute one step or you can substitute all the steps. So like you can do here, you will get the substitution for the next step for this boost MPL, let's see, call. And in the end, you'll get that D type for the high variable. So if you would like to understand what's going on behind these types, you can unbind it in that way. So, and again, it's like step-by-step substitution is useful because you can stop at any point and decide that that's enough for me. And now, templates, meta-information, meta-programming, how to deal with that, how to debug it properly, how to understand it properly. Instantiation the templates, it would be always very nice if we could understand which template was instantiated and which types were used for instantiating the templates, how it was all how it all was actually done. So talking about these, how the modern tooling supported, what I really love is how this develop tool, that's an IDE built on top of Eclipse, done by some people in the university in Switzerland. So maybe that's not a very known tool, but it's a very nice tool, especially in terms of that very feature, when they can show you the instantiation graph. So that's just one step here, but if there are several instantiations, they will show you the chain with all these windows, and then they will show you which types were used for the substitution for the template parameters. So the ways it's done in Eclipse or ReSharper C++, it's just when you hover on the actual instantiation, it shows you some kind of function signature with the types substituted here, so you can know which types were used for the substitution. The thing that I will be a little bit dreaming in that slide, so that's not a real thing, but I will be trying to explain that that's possible somewhere in the future. I'm pretty much sure it will be possible. So what I want here is I have this const expr in my getValue function. So every time I'm actually doing the instantiation for this template, I'm using one or another branch. That's obvious. What I would like to do is I would like to come from the actual instantiation and see the active branch. What I'm saying is that it's possible. The idea actually came to me after I saw that feature nearly 10 years ago in kdevelop. They had a fantastic feature that was looking like that. So when you were navigating from the template instantiation, it was using this particular type for particular information from the actual instantiation to show you the code intelligence and completion in the actual template body. They removed the feature because they moved the engine to Clang and they haven't re-implemented the feature on top of Clang. But that was a very nice feature, and hopefully we can do that somewhere in the future, because that would be very simple for all these compile time expressions here. But yeah, since that's a question mark, because I don't know any tool doing that right now. Yeah, some template intelligence features. So there are still features coming for debugging the templates and dealing with the understanding what's in there in the template body and helping you to write some code or read some code in the template body. Like what Visual Studio actually did last year, they added some UI where you can actually add the type that you will be using to instantiate that template. So when you're just on the template body, you can say, okay, I will be instantiating this template with these values. And you can add several sets, several options here. And then it will be using these values to show you, for example, the completion in the template body. And that's very obvious, because usually when you write the template, you more or less know which types you'll be using to instantiate it in many cases, or at least some general type. So definitely the concepts will help here, because we can take this information from the concepts in future. But right now, when we don't use them actively, so this feature is very useful. So you can just say that reactively that I will be using this type here. A very similar thing that we've implemented in ReC# or C++, we're just using the default type information to provide the IntelliSense. So because if there is in the template body, if there is in the template definition, if there is some default types, we can use them to show the completion, for example, or show you some parameter information in the parameter portal window. So it's very similar. It's some proactive help. So just taking the default values here. Okay, now let's move to the overloads. So we'll start with the operator overloads. So the goal is here to understand that these are different operators, even if they look the same. That's very time-consuming features, so that really requires some nice performance stability from the IDEs. So that's what we did in C-line, where that we highlight you the same operator, the similar operator. So if you put the cursor on that operator here in that line, we'll highlight you others that are just the same. These are the overload operators for my fraction class. And you can also find the usages. So if you go to this overloaded operator and say find usages for me, we'll find all the usages for the overload operator. But the drawback of that feature is that it's really time consuming, because you can guess, you have to analyze all the operator usages and to try to find out, to limit it somehow nicely to understand which one actually fits the overload operator. But it can be very useful when you try to understand if that's a regular operator, some standard one or some overload one. Talking about the function overload. As I said, the algorithm is pretty much straightforward. You just build the set, you filter the set, and you select the proper candidate. So how the tooling can help you? So first of all, it can show you the full set. That's what most of the tools currently nowadays are doing for you. So they're trying to show you the whole set, which more or less fits your actual function call. In Visual Studio, you can just list through this set. Maybe not very convenient in terms of looking at the whole set at once, but you can just go for it step by step. Other tools are just showing you, C-line is showing you the parameter information. So taking all the overload candidates from the set. Eclipse is showing you the whole function signatures for all the functions that actually was considered in the overload set. And ReC# or C++ does the same on top of Visual Studio, adding some documentation for the function to the information. So okay, we can guess the whole overload set, but how we can answer the question why this actual candidate was selected? That's a very tricky thing. And I don't know a good way to do that in the tooling nowadays. But there are still some features that could help. That's what we tried to do in ReC# or C++. We first of all added the name hints, so that if you have different names for your actual arguments in the overloads, you can more or less quickly see which overload is used here. And we also try to add some additional information, if some overload, some function was deleted, so we put just this delete in this information so they can see that. But there are no good ways actually to answer the question why this overload was selected. So the Clang is actually trying to do this job partially. So when you see the Clang error for the overload, what it actually says to you that these it can provide you some information, here it says that no matching function for call to bar, candidate template ignore, substitution fail, no member named method. So you can get some information why the overload actually failed. So it tries to answer you, because I don't find this method, or something was deleted, or some concept was not satisfied in the future for the concept. So the Clang compiler is trying to do that. And in ReC# or C++, we've also added some cases which Clang currently doesn't cover, but hopefully it will be covering them in future, for the conjunction V the clang here in that last case, the clang just saying that the conjunction V was not satisfied. So in ReSharper or C++, we're trying to explain why it wasn't actually satisfied. So that's what the modern compilers try to do, trying to explain you why the overload failed. That's a very good feature, actually. Not all the compilers are unfortunately doing, like Microsoft, unfortunately, is doing quite a bad work in terms of explaining the overload fails. But that, again, works only when the overload fails. But what if it works? There's no currently, at least I don't know any good tool that will explain to me why this particular overload was selected when it actually was selected. Like when everything fails, like it's clear enough, the compiler will fail, it will provide some information, maybe the tool will show it for me before the compiler actually goes in work. But unless just looking at the whole overload set, unfortunately we don't have anything here. So that's like the second thing I'm dreaming here about, is about like in the future I would like to get the tool that will provide some explanation to me. And talking about the overloads, there is one also very nice feature which I like, is that the overload might work, but it might not work as expected because some signatures are not matched correctly because maybe I did some mistake, for example. And so in Visual Studio and in ReSharper C++, there are features which actually help you to navigate to these unmatched function signatures, like I try to run it. So here, that's how it works in Visual Studio with ReSharper C++. So when I have a function, I can navigate, then I can add some extra argument. Definitely, it should be broken now because I can't navigate, the function doesn't match. But still, it tries to understand that maybe that was the function you were thinking about, and you just want to fix it. And so I will navigate you to the unmatched function signatures. That's always based on some heuristics, so definitely it's not the like 100% correct way because this function signature doesn't match. So you can't be 100% correct, but at least it can navigate to some similar functions. And the Visual Studio also doing like very similar thing, but just using some different heuristics here. So that was about the overload. And the last part I would like to touch here is maybe not directly connected to this, like understanding the macro or the typedef or the overload set, but that's about these understanding what's going on in your projects in terms of the headers and all the includes you have. Like in 2011, this article was written, and the tool was actually written, which was called Header Hero. And I'm pretty much sure the authors of that tools are heroes, because they wrote a tool that could actually, that is trying to understand what's going on with all the includes in your project. And the story behind is that when you start with the project, it's very nice and small and tiny, and I don't have a lot of includes that you don't need because you just started. But when the time goes on, more people are coming to the project, more maintenance is happening, more includes were added, and at some point you get lots of includes. Some of them are necessary, some of them are somehow intersect, there are some defines, undefines, whatever. So, and the authors of this article, they are actually calculated this blow-up factor. So that's the total number of lines parsed divided on the total lines of the code. So, and the total number of lines parsed, that includes all the headers substituted. So, and so any header that's included in several places, it actually adds several times to that value. So, and they were running that tool, so which was calculating this blow-up factor and shows all these total lines and total lines parsed. So they implement that tool called Header Hero, and they were also showing these biggest contributors to that number. And the blow-up factor, it's actually quite a scary number because they calculated for some big projects that sometimes the blow-up factor could be for example, 30, which means that every line of code was parsed 40 times in average. And the good question is, do we need this number of includes? And so how you can understand that you don't need them? So they do that in that way in the Header Hero tool. And we just implemented a very similar thing in ReSharper C++ with some nice UI, just showing you all the files in your projects all the number of times included for each file, and the line contributions, inclusively with all the headers. What you can do now, you can just go to this window, sort by that column, take the winner, and try to understand if you need that number of contributions to the project from that file. There are some tools which are trying to do that optimization automatically, luckily. So one of it is easy way to deal with that problem is to use the precompiled headers, but there are like pros and cons for that. So the good way is probably to try to run some checks on your code. The first basic checks is that most of the tools are nowadays doing for you is showing you the unused includes. That's kind of basic check for the modern IDEs. Many of them are doing that. So they're just highlighting you in some way that this includes is maybe not needed. Then it's up to you to check. Maybe the tool is not right, or maybe it's suggesting you some good thing, then you have to remove it. There is also include what you use. That's a Clang-based tool, which tries to remove the unused includes and to substitute some with the forward declarations. What I like about this tool, and I like about the authors of that tool, is that they have a very nice page on GitHub that's actually explaining why include what you use is difficult. So they are trying to cover some tricky cases where the tool might fail and explain why they are tricky. So, because if you think that that task is very easy, it's not. And yeah, include editor is a very similar tool. It's from Eclipse, and it's doing a very similar job to include what you use, but just it's include what you use is based on top of Clang. Include editor is just using the Eclipse internal engine, also to remove some unused includes and to change them to use forward declarations instead. So yeah, and these are the options how you can like proactively deal with this blow-up factor which is growing. So this is a very nice slide which you can use. This is the reference. So you can find all these nice talks I was referencing here, and some like these discussions about ranges. If you haven't heard about it, just read it. It's interesting in terms of how the people feel about the language. And some surveys I was talking here about, and the last link is the up and running survey from JetBrains about the ecosystem. I really encourage you to participate because we need more C++ developers like fill in the survey to understand what's going on in the ecosystem. And so that's it, and we have some time for the questions. Thank you.